Hey, how's it going, everybody? Dr. John here for Extract Talks. Hope you guys are having a good day today. We're going to be continuing our series on GMP fundamentals, product and process considerations. We only have like 6 more weeks, 7 more weeks on this. At least that. So I hope you guys don't get really bored. There are some of you who are leaving comments. Thank you for doing that, by the way. It's kind of encouraging us, you know. Oh, I know this is a really boring topic, but please keep doing these because they're informative and whatnot. So, yeah, we'll keep doing them. Hopefully we don't destroy our podcast in the meantime. It's like, oh my gosh. Nobody really wants to talk about facilities and facility design and that stuff. I mean, but you know, we're going to go over some of the key architectural, GMP requirements today. It's going to be a lot of fun. Guys, let's talk about GMP fundamentals. Before we get started, why don't you guys click on that subscribe button on YouTube if you're watching this on YouTube. If you're not, you can subscribe in a different way, however you want. Just go to our website. There's lots of ways to subscribe. Mm-hmm. Also, there's a little thing on there that I didn't realize that you can push a little button and it will, if you subscribe to a channel, it'll tell you, hey, there's a new video. Mm-hmm. And that's a notification button.
The notification bell.
Oh, that's pretty sweet. I didn't know about that before. That's really cool. I was like, okay, because I always went back and then, you know, sometimes you'd be episodes behind and some of the other stuff that you were doing. So anyway, so here's the GMP fundamentals, product and process considerations. Again, you guys know us. We do mini courses, we do product tours, we do podcasts, we do guides, calculators, so on and so forth. And we make really boring content that is actually quite popular. Mm-hmm. We hit 1 million views, guys, on YouTube. So why don't you go ahead and take a look at that. We're having a good time. Process for creating APIs. You guys have seen this before in final dosage forms. You got the inputs, the raw botanicals, the solvents, all leading into a GMP facility where there's an API output. You have your cannabinoids, your other isolate, your winterized, your distillate that's really feeding into that. You add those with excipients to create formulations, and then those go into final dosage forms. Those would be, what do we say, like capsules? Tinctures, things like that. And then you put those into packaging, lotion of gels. You got it all set. Here is ICH. We have been talking basically for many weeks now on Q7 and good manufacturing practice. You can see that we could literally have easily a year's worth of topics.
Going over every
paragraph, line by line. And we kind of are doing that in a lot. We talked about the general principles of GMP, risk analysis. We've talked a lot about how to really do that risk analysis, right? We'd spend a couple of weeks on that. But today we're going to be talking about architectural things. So, because we really haven't talked specifically about architecture. So, design and construction. So here's what we're going to be talking about. Buildings and facilities used in the manufacture of intermediates and APIs should be located, designed, and constructed to facilitate cleaning and maintenance and operations as appropriate to the type and stage of manufacture. Okay, so what does this buildings and facilities used? What does this have to do with architecture? Well, it has a lot to do with it, and I'm going to go through some of those aspects just in the subsequent slides. But I thought we'd just kind of go over this because these are the requirements. Facilities should also be designed to minimize potential contamination. We've been talking a lot about that. Whether it's external contamination or internal contamination, where microbiological specifications have been established for the intermediate or API facilities should also be designed to limit exposure to objectionable microbiological contaminants as appropriate. And they should have adequate space. Obviously, you want to have that so that to prevent mix-ups and things like that. And then you got to make sure that you have good and adequate flow of materials and personnel through the building to prevent mix-ups. I think we've talked quite a bit about that so far. Yeah. Must have hit that topic on many different occasions. There should be defined areas for receipt, identification, sampling, quarantine, incoming materials, pending, release, rejection. So these are defined areas. They can be all, some of them can be in the same space, but they have to be a defined area for those items. API holding, rejection. So these are all QC functions here. You have to have enough space in order to do your QC work, which is the fundamentals of quality within your API production. And then packaging and label operations and laboratory operations. Okay. Adequate clean washing and toilet facilities should be located for personnel. See, I have this underlined right here. Toilet facilities should be separate from, but easily accessible to the manufacturing areas. Oh, no. You wouldn't believe how many plans that I've seen where the architect has put the washing facilities or the gowning facilities or whatever right in like the processing area. You can't do that, right? The other thing is you want to make sure that you have, adequate washing facilities so that, what you're doing right now and the number of people you have right now, you'll be able to accommodate your growth in the future. But you have to kind of keep that all away. You can't have it in the same room. I mean, it's pretty obvious, but I'm pretty surprised. Here's one thing that's a little less obvious is the laboratory operations should normally be separated from production areas. Some laboratory areas in particular are used for in-process controls that can be located in in-process areas. So what they're saying is if you have an in-process laboratory, you can have that in a process. But if you're going to have like a general functioning laboratory, it should be kind of separate.
I see.
So those are some of the key aspects here. So what are some of the architectural considerations then of the GMP facility anyway? Well, here, let's go over some of these design principles. The first is design should be congruent with the product quality risk analysis. We've talked a lot about that, how to do that. But if you have, for example, a severe, risk analysis, and you've identified that risk analysis and you've identified the risk to quality, to product quality specifically with a high level of exposure, basically that will help you define the levels of protection. If your product is exposed out into the atmosphere, obviously that's going to require a higher level of protection, right? Same thing with selection of materials and finishes. Those are typically what the architectural person does. And, these things we're talking about the ceilings, the floors, the floor coverings, the wall coverings, the seams, the type of fasteners that are used, the type of doors that are used. Right. And this can get, there's not only the GMP requirements, there's also sanitary requirements, and there's fire requirements on top of that. So sometimes you really have to be able to unpack all those things. An architectural plan must address cross-contamination risks. That's not only including your building, but also, in your site plan. Like if you're downstream from a cyanide factory, and the prevailing wind is in such a way, where you're where your input, I don't know. Landscape too, birds and rodents like to, kind of congregate in landscape. And a lot of people like to have their landscape right up against their building, but it's not actually a good thing to do in terms of potential contamination. Mm-hmm. The other thing that's a lot of architects like to use, horizontal members, in their design, right? Like you might have an horizontal shelf, or you might have, a wing style roof protruding out from the front of the building just to break it up to make it look good. Well, those are the types of things that really harbor, birds, and, it's very hard to maintain. So those are the types of things that you would want to think about if you're thinking about getting a new building, or getting a building, buying it existing, or building a new building. Right. You want it to be architecturally pleasing, obviously, but at the same time, you don't want to, harbor rodents and insects and things like that, and birds, and, you're looking to try to think about how to really help yourself there. One of the things, like if you're building a new structure, you might want to, pour an apron out from the bottom of the foundation, so that you prevent, like rodents from coming under it. You know, that's how they get in. Basically, they can bore in and do all kinds of things. You know, yeah. The other thing would be like, you know, like typically you have all kinds of different styles of roofs, right? I mean, and one style would be, basically with rocks and tar on the top, and so that would not necessarily lend itself well to maintaining a clean environment, especially if all your HVAC's up on the roof, right? So you might want a smooth membrane instead of, rocks and tar and stuff like that up there. So things like that, a good risk assessment will take into account, what's around it, what the landscape is, what the, how to really, build in hygienic design elements into your architectural design. So what are some key factors for product protection? And we've kind of talked about this, but we're going to look at it. We've talked about this in other contexts, but we're going to look at it now in the context of an architectural design. So production space for environmental quality, exposure to environment in the space, and containment systems used in the space. So it's pretty simple. There's only 3 things, but these are really the key factors. You got to really control that environmental quality of the, in the room. And that's actually, it's not easy, but there are very good standards out there for that. So like they have the ISO standards for the room. So you can take a look at that. Let me see here. So room space, environmental factors that may influence quality, humidity, temperature, particle load, light spectrum. Like for example, if temperature doesn't really have any impact on your product quality, like for example, it's perfectly stable, even if it was warm in the room, you might still have, like a comfort level, obviously temperature, maximum on your room, or temperature range on your room, right? Just for comfort purposes. Personnel and people, you don't want them sweating or, possibly contaminating the product that way, right? So even if there is no, environmental factor that would influence the product quality, there may be, other things. Humidity, for example, you might just not control humidity at all, or maybe humidity has a huge impact on, say, whether you're talking about a product that, breaks down under high humidity, right? So, you wouldn't want to do a drying operation and then have it super humid in there, right? So that's an example. A good example of this in hemp world would be, you have dry material coming in, and you're going to store that dry material. How do you store it? Well, you want to store it in a cool, dry place, right? If you store it in a hot, let's say humid area, the hemp or the marijuana is going to, reabsorb the water, right? And it will rehydrate a little bit, It'll take some time to do that. It just depends on the humidity that's in the room, and if there's a lot of it.
Airflow.
Yeah, airflow, right, exactly. Airflow in the room. Good example there. Particle load in the room, or light spectrum. Suppose you have a product and, it's really sensitive to light. It's going to break down. It may be sensitive to the small amount of UV that it's going to be exposed to. So those are the types of environmental room factors that will influence the architectural design, and it will also influence what that designer has in the room. So things that you need to think about, and also are directly applicable to what the Q7 just told us, And
the particle load is like the dust particles?
Yeah, dust. Yeah, so that's where the HVAC system comes in, and people, typically would define, what the HEPA level of the room is, and what the filtration efficiency associated with that HEPA level would be, and then they would, design a HVAC system for that particular room, depending on the risk of that. So, and the levels of protection required. So, second thing would be control of environmental exposure. So the goal is here to reduce the environmental exposure as much as possible. And again, here's some principles. Instead of having one large room, breaking it up into smaller rooms so that you can control those small rooms is probably a really good idea. So if you look at GMP facilities, oftentimes there's an insane number of rooms, and that's because they're trying to control and break up the requirements of the rooms that would have less requirement to the ones that would have more requirement, right? And therefore, you're trying to control a smaller area. Therefore, you're more successful to, be successful in your levels of protection. So, the other real general principle of controlling environmental exposure is obviously the use of containment systems. If you can eliminate, the risk of exposure of the product to the environment itself, you should do that as much as possible. So, usually the levels of protection are predicated on what the exposure risk is. Is it where you only risk exposure for a small amount of time, or do you have no exposure risk, or is there open use? So, if you can, you should use containment systems. And from an architectural perspective, that kind of goes back to, what equipment is being used. But oftentimes, the architect can help out with, just kind of encouraging, hey, look, well, this is the cost that it's going to, take to make all these rooms like a level 3 level of protection. It's going to cost you a lot. So let's look at maybe, reducing the number of rooms that we have to really control and adding in some containment systems instead. A vessel that has a controlled inlet and outlet. So supposedly you're doing an extraction, right? And you want to take the oil out of that instead of, putting the extractant into a bucket that's then open to the atmosphere. Right. You would have it in a closed environment where you would put that into a vessel, and the vessel would be a pressure vessel or maybe not. And it would be close to the atmosphere then. So that's fully contained. Then you can move that around to wherever you want. It's even better if it's continuous, for example, kind of getting into equipment and things like that. But if you can go from, for example, extraction to distillation all in a continuous system the way that we do, you're able to really, really do that. Oftentimes people like to break those systems up into separate systems so they have more versatility. That's the main reason why people don't have continuous systems, because they want, for example, winterized oil out for their tinctures. They want distillate oil out, or they'll want isolate in a separate process. So they typically like to break it up so that they have the streams coming out. Mm-hmm. But if your goal is to eliminate any environmental exposure, well, you're only getting one product out at the end by using a containment system, right? So use of separate material in personnel quarters. We've kind of talked about this before. That would help with, basically limiting environmental exposure, where, the environment would come from, say, the material itself. A lot of times people want to make sure that they have their material and make sure that they have gone through a kill step with their material so that the bugs don't stay in the material, and then they end up either hatching or, crawling out. So it's very important that when you're talking about a material of biological origin or a raw material, that it is either gone through some sort of kill step, so you're killing all the bugs that are in it. You can do that with various ways. Let's think of the ways we could, we could gamma irradiate it. That's the first thing that comes to mind. Cyanide, cyanide blends would be good.
Correct.
Scorched earth. Let's see here. We could put it into an inert environment, for example, that was exclusion of oxygen, that excluded oxygen, like argon or CO2. A lot of times you would, in a kill step, you would actually remove it from a bag or remove it from the bale, and then it would go through the sterilization step. You got also have separate raw materials from processing. Separate the raw materials from the processing itself. That's really what we're talking about there. And we just kind of talked about that. If something's coming in, you want to make sure that it's separate from your processing areas. And then you can design HVAC systems so they don't cause contamination. So those are some of the factors that principles that really go into, hey, how do you control the environmental exposure? And then prevention of product contamination. There's just a bunch of different ways that you can do that, but you can reduce or eliminate overhead piping, for example. All of that piping, if you go through a facility, you'll see that all the like horizontal members, right? Like whether it be structural members, for example, like grids and girders and things like that, they'll all harbor like dust on the top of them, right? And then that will continuously accumulate over time. And so either the company has to have a good maintenance program, and that's on a schedule that shows, hey, we've gone up there, we've cleaned all that off, or they can even order their building in such a way as to reduce or eliminate those horizontal exposures. You know what I mean? So they could close it up, for example. They could put a ceiling on it. They could, a bunch of things that you can do. But overhead piping is one of those things where, the top of the pipe gets filled up with dust, right? Yeah. So obviously, it's a requirement of the Q7 that's maintained and that it's cleanable. Okay, so when you're talking about piping, got to make sure it's smooth so it can be cleaned, right? If it's porous, like an insulation, for example, you want to make sure that you have a cleanable surface on there. Right. Yeah, so that's the type of thing. Using the radiuses at the walls, floor, ceiling interfaces. Oh yeah, curvature, so you can clean it. Anything with an acute angle, like nuts and bolts, maybe that are sticking out of the floor, holding up and bolting structural members, vertical. Those are the types of things all the way around that will harbor all kinds of dirt and dust. So you need to either caulk around them or you need to eliminate them by covering them up. And so, you can do that with walls and, stuff like that. So other things that are maybe not so obvious to prevent product contamination that have a lot to do with the architectural aspects of the building is the exhaust and air intake locations. So if you have, the exhaust and the air intake right next to each other, usually you want to generally put those away from each other as much as possible.
The flow goes throughout the entire room. It's just looping around itself. Yeah.
Right. So if you have an aroma coming out of your, out of your grow area, you don't really want to be piping that into the air intake of your processing area, for example. That's something that you need to think about. HVAC room pressurization, that'd be another thing. So if you have a dusty area, for example, if you're in a grinding area, or you're doing, maybe there's a point at which you're exposed to actual, powders. In those areas, you probably want to have under negative pressurization. So those are the things that when you make your MEP plan or your mechanical, electrical, and plumbing plan, typically your architect will be coordinating that with those engineers. Room pressurization is a key aspect to making sure that, if all of the dust is blowing out of the room because you have it overpressurized, right? Right. So you want to make sure that the dusty areas are negatively pressurized relative to all the other corridors around them.
Right. And that you have a specific room for the dust.
Right, yeah, right.
Or for the grinding. Instead of open to the air.
Open to the air, right, exactly. So you want to have it in a room. You want to have it under negative pressure. Typically, you want to have, other things there that also prevent cross-contamination, like booties or specific gowning criteria and protocol. Also, maintenance of those areas, like the lights in the areas. You don't want to have, horizontal members on there, right? So if it's sticking down, the light is sticking down from the ceiling, you don't want to have a bunch of
shelf right there.
Yeah, you want to have it flat to the roof. You want to have all of your materials, your rooms, so that it can be washable, so that even the ceilings and the doors, and that goes for the hinges and the nuts and the bolts, and maybe if you have fasteners that are sticking out, you don't want any square heads or hex heads on those at all. Seamless is best, and if you can't get rid of seams, you got to caulk it. So those are the types of things you got to do.
I suppose that you already addressed that, the gowning area, because most dust comes from people.
Yeah, right. So yeah, exactly. So yeah, they come from people, those dusty people.
Well, it's hair, it's skin fall.
Yeah, exactly. So yeah, I mean, if you have the gowning area, then you have levels of control. Your gowning level should also change with the level of control. Yeah. So also, I did already talk about the smooth membrane roof and elimination of acute angles and things like that. And then also the elimination of horizontals. So a bunch of different things, principles, I think, just ideas. These are just what came off the top of my head when I was writing up the slide. There are many, many more.
Right.
So when you get into it, you guys should probably look up. There's a lot of really good guidance in the hygienic literature. So if you apply a hygienic code to your building, it's probably really good. It has a lot of things that you probably didn't think about in your hygienic code. So, and there's been a lot of good articles written on that as well. So go ahead and look up that architectural hygienic codes. So, okay, let's now talk about functional areas. A lot of times architects and architectural people want to know, okay, what are the functional areas in GMP facilities? Typically you have support areas, you have storage areas, you have corridors, and you have processing areas. Okay, those are the typical areas. You could also add to that laboratory areas because sometimes you have laboratory. I don't want to also ignore that the possibility of having outside utilities or even outside processes. If the unit does not have contamination risk, it can be placed outdoors. You can do that, no problem at all. The only thing is that when you bring it back indoors through a pipe or whatever, it has to be caulked, so that you don't have, bugs or, rodents getting through there.
Outside.
I think like a 1/4 inch. If you can see light through it, they can get through it. It's crazy. Those guys, those little mice. Okay, so support areas, locker rooms, gowning areas, break rooms, utility rooms, warehousing. Those are typical areas you don't really need to have a lot of protection. You don't need any protection, actually, because there's really no, in those areas, since there's no product in those areas, there's no risk to contamination of the product, so there's really no need for protection on those, I think that the main thing there would be, like if you have a locker room, you want to make sure that there's no, like the outside is landscaped enough so there's not tracking in of mud and or dirt or so those are the types of things that you need to be thinking about with those. Also, storage of materials and products. So you have control areas. That's something you need to think about. Those are fire control areas. And, the IFC has basically in table 5003, they've really taught you how to, establish control areas based on the amount of solvents that you have, open use, closed use, and in storage. So go and look for control areas. But typically where you have a storage of materials, you also have to have a separate plan for your storage of your solvents. And that may be outside, for example. Vaults would be another thing that you need to be thinking about, and then separation of the raw materials in process finished goods and all of those different quality functions that really we talked about in the Q7 just a couple slides ago. Also, corridors are pretty much given in GMP facilities. These are materials, there's personnel corridors. There's also, like we often, when we do designs, oftentimes we try to put in a utility corridor or utility area, just so, those rooms you can sink the, you can sink all, those are utilities typically generate a lot of heat, right? If you can put them all into, a generalized, single location, it's really good because then you can close it off and dump the heat in there. And you can do it rather economically rather than, running it through the HVAC system, which you might have in a level 2 or level 3 area, which is much more expensive. Right. Do that. All right, guys. Thanks a lot. And thanks for joining us, and take care. See you later. Bye.